Current in the 8 ohm resistor in the drawing is 0.5 amperes. So ignore for the time being this R10, R5, R1. That is all that all these things written by hand. Do not watch at this point. You just see that printed thing. So current through here is 0.5 amperes. Now we need to find current through here. 12 and 9 through here. Where is 12? We need to find all currents, and effectively we need to solve these circuits. So what that is, So first of all, let us find where is 12 volts, 12 ohms resistor. Oh, this is 12 ohms resistor. So we need to find the current through here, and through here. So we need to find all currents and all voltages, more or less. But we have current through this part here, and we have its resistance. So we definitely know by the Ohm's law that the voltage between those 2 points is when you multiply those two things. But voltage between those 2 points is exactly the same as the voltage between those 2 points. And so on. And then, when we find that current, this current through here and through here will add here and will make this E2. Let's say like that. For more precise, look for the Kirchhoff's current law. Okay. Let us first find the currents to okay, this is voltage. This is the voltage between those 2 points. So U is equal to U here, and this is R1 is equal to R E. This is I16, this is 16, and this is 8, this is 8. Let's say print whatnot. So voltage is the same as I said before. This is not necessary. Voltage between those 2 points is the same as between those 2 points because they are in direct connection. So that is U is equal to U, and 8 ohms times 0.5 amperes is equal to 16 ohms times something. This unknown current. And from here, this unknown current is 0.25 amperes. So we have 0.25 through here and 0.5 through here, so they will meet here, and current in this branch here will be 0.75 amperes. We find something. Okay, let's move on. And now we start with the B. We need to solve everything else. First of all, we need to find some equivalent resistances in order to find all the currents and all voltages and whatnot. So we will start with this because we have everything. So equivalent resistance for this part of the circuit here I noted as R1. And as you can see, these two things are in parallel connection. Then I noted this R2 to be equivalent resistance of everything here. And R2 is this thing here in line, in linear connection with this here. So resistance between this point and this point will be R2, and we'll calculate this plus this, and this is in parallel with this, and so on and so forth. And you could solve every kind of complicated by simplifying complicated circuit, but simplifying it like this. And this is my invention, I think. Okay, that is 1 divided by R2, that is parallel connection, 1 divided by 8 ohms, plus 1 divided by 16 ohms, and R1 from there is 16 divided by 3 ohms. And now, R2 is R1 plus that in connection, and this is R2 is 76 divided by 3 ohms, and current through that resistor is, we just calculated to be 0.75, and now we can find the voltage VDF to be this times this. Why is that? Well, because we have current that is E2 here, and we have that resistance is the same current here. So voltage from this point to this point is exactly the same as you can see voltage between this point and this point. Because this point is directly connected to this, and this point is directly connected to this. It's also connected to this and to this, but does not matter in this point. So voltage between those 2 points is equal current time equivalent resistance. And we did find that to be VDF is equal, what? 19 volts. So voltage between this point and this point is 19 volts. So same thing. Voltage between this point and this point is also 19 volts. Why? Because they are direct connection. But also, as you can see, this is a direct connection. So voltage between this and this point is exactly the same as voltage between this point and this point, because they are in same. They are all on same voltage here. So from here you could do it yourself, or for extensive and long written answer, you could follow the link in the description. If you want more of this, you could subscribe and tell your friends. Thank you. Bye.